Okay, so let us chat about results tables. This is part of your alternative to prac paper, and what they're going to do is they're going to give you data, and then you're going to make a table. So it's the same thing as if you were actually in a practical, doing the practical, collecting the data, then making your table. So we're still working on exactly the same skills. It's just that they're going to give you the data rather than you doing the experiment to collect the data. So let us think about some rules. First one is, let's just give this a heading so that when you read it later, it still makes sense. Rules for results tables. Okay, first one. Draw your squares with a ruler and a pencil. So I found that I can do funky stuff in here. So I think, haha, there's my imaginary ruler. Whoa. Okay, how do I draw another line? There we go. Okay. So you see how beautiful and straight my lines are? And you see how they're in the gray of pencil? Okay, that is because I'm using a pencil and I'm using a ruler. And there's my results table. Okay, next thing, that one again. You're going to put your data in ink. Okay, we're using dark blue or black, so we're going to be good. Let's call this apple. And time in. We're getting a little bit dodgy. We shouldn't be making up things as we go along. Okay, so we will be good. We will just write heading units. Okay, we'll play safe. Heading units and heading units. And then let's actually be a little bit more proper with our table. Give him some other cells. Oopsie. Okay. Then let's go A, B, C, 2, 2, 4, and 12, 13, 11. Okay, so our data is there in ink. Next rule. Each row or column has a heading. Okay, so each column we're going to go with has a heading. Because this is the way that they always do their tables in the past papers. So match the same style for yours. Okay, and there is our headings. They're in our top row. Okay, each column has a heading. You can't draw a table that looks like this. This is not a table. This is some sort of strange thing. Okay, tables have all their squares and they have a heading in the top row. Okay, so you saw here when I wrote my magical mystery headings, I wrote heading slash units, heading slash units, heading slash units. That is because that is where the units go. Units only go in the heading. I don't write 2 minutes here. I put heading minutes. Okay, there's no millimeters here. It would be up in the heading. Units only in the heading. They actually take marks off you if you put units in your cells. So really avoid it. Okay, next one. How do we know what to put where? This first column here is always our independent variable. So, independent variable in first column. Now remember that independent variable is a thing you're setting. This beaker has warm and this beaker has cold. I'm measuring at 5 minutes, 10 minutes, and 15 minutes. It's the thing that you're controlling and that you're changing to see the effect. And we see the effect on the dependent variables. So subsequent columns, maybe it's one, maybe it's more, are your dependent variables. Okay, so subsequent columns are measurements of the dependent variable. Okay, so whenever you start to read a question, one of the important things to do is to have a note and have a look. See, where's my dependent? Where's my independent? Okay, what am I looking at here? Because then when it comes to the results table, it makes it easier because you know, that one in the first column, those ones in the subsequent columns. Right, so are we happy? We've got our rulers, we've got our pencils, we've got our pens. So we can draw this table properly. We're going to have boxes around everything. Okay, each column has a heading and our units only ever go in that heading. Okay, then we have our independent variable in the first column, left-hand side, and then our subsequent columns are measurements of the dependent variable. Let us go and now do some past paper questions so you can see how this actually works. So, should be this one. Okay, and I've got a nice green line, which means that you should be able to see exactly what I'm looking at. So, results tables, practice questions. We have to look a little bit at the experiment in order to see what the questions are. But then we can go ahead and do it. So we're not working through the entire questions. Okay, so this is, first one is an extract from Summer 17, paper 63. And we have a student who has set up an apparatus as shown in figure 1.1 to determine the vitamin C content of 3 different vegetable juice extracts, P, Q, and R. Haha, what are we changing? We are changing 3 different vegetable juice extracts. This is our independent variable. Which vegetable juice is it? Okay, and we've got 3 of them, P, Q, and R. So we set up, okay, we have our conical flask with our vegetable juice. We're doing P first, and we've got starch solution there, and we're testing with iodine solution. Okay, so then they step us through it. Conical flask was labeled P. 25 centimeters cubed of vegetable juice extract P was added. Okay, 1 centimeter cubed starch was added, mixed well using a glass rod. Well, that's good. They're giving us nice, precise instructions. Okay, we like things like that. Then a 10 centimeter cube syringe was filled with iodine solution. So here's something that's actually important to note. When we're doing small volumes, then we usually use syringes to measure those volumes. So, fast forwarding, figure 1.2 shows the volume of iodine solution that was left in each syringe at the end of the investigation. Each syringe contained 10 centimeters cubed of iodine solution at the start of the investigation. There's P, there's Q, there's R, 3 different extracts. Right, so use figure 1.2 to calculate the volume of iodine solution used in P, Q, and R. Prepare a table and record these results in your table. So, at the start, we had 10 centimeters cubed. And if we take out what is left, so 10 minus what is left, we're left with what is used. So, if we now go and read these syringes, we're going to zoom in so we can read them nice and easily. Okay, so the iodine solution is all of this gray stuff. And if we look, we go, there's a 0 and then to 1, so that's a 0.5. So every time you do something like this, you need to check the calibration because they might give you a syringe with a different scale on it. So always double check. So there's 1.52, and there's the end of our pale gray. So that's 2.5. So we're very zoomed in, so let me write a bit bigger. 2.5 left. Okay, let's do the same thing for Q. Okay, we can see 4.5. Here we are, changing to 5. So we've got 5 left here in gray. And if we then go look at R, we can do the same thing, 1, 2, 3, and there's the end of the iodine at 3.5 centimeters cubed. So zooming back out again, for a more comfortable level to write at, we started at 10, we're left with 2.5. So we don't have much space for our table, so let's do our calculations here. So P is 10 minus 2.5 equals 7.5. Q, 10 at the start minus 5 left equals 5 used. We'll be good, we'll put our units. And R, 10 at the start minus 3.5 left equals 6.5 centimeters cubed used. Because we want to calculate the used volume. They even put it in bold to make it really stick out. Right, so here are the results that we have calculated. Now we want to put them into a table. So what is nice is to pick up your pencil and actually give yourself a little bit of time here to think about what is in my table. Okay, so we have our veg juice extract, and then we have our iodine used in centimeters cubed. What this helps us do is to plan out and make better use of our space when we actually come to drawing our table. So I don't have nice rulers anymore. So this is going to be a case of you're going to trust me that I am doing my absolute best in order to draw these straight lines. Okay, so gray, pencil, preparing a table. So I'm going to fill my space and give myself plenty of space to write in the table. I need 2 columns. Okay, then I'm going to need 4 rows because I got the veg juice and I got P, Q, and R. With a ruler, ladies and gentlemen. Okay, now, headings with units in that first row. So this one would be, whoa, not in pencil. We now switch to a pen. Vegetable juice extract. P, Q, R. Now there's no units for that one, so we don't have to worry about units. So then, this is our independent variable. Our dependent variable is what we measured, and we measured, well, calculated the volume of iodine solution used. So, volume of iodine solution used, and here we have units, so they must go up the top, centimeters cubed. And then we can very simply put in our data. For P, we used 7.5. We don't put centimeter cubed again because it's there in our heading. Q was 5 and R was 6.5. So now we have our table. It's so straightforward for anybody to read, to see the data from here. Okay, if you want to look at it, you can say R used 6.5 centimeters cubed of iodine. Sorted. Okay, so this one is an example. Okay, I've got 3 examples here of results tables, and each of them is showing a sort of different situation. So this one is where they are giving you apparatus that you are going to read. So, you must read info, data from images of apparatus. So in this case, it was a syringe. It could be a thermometer. It could be a measuring cylinder. It could even be a stopwatch. Okay, anything that you would use in a practical is something that they could give you a picture of and say, what's the reading on this apparatus? Okay, so one beautiful results table down. Let's get another one going. Okay, our next question comes from Winter 16, paper 62. And here the question is all about germination. Okay, and germination with seedlings growing in the light versus seedlings grown in the dark. So let's change color to keep life interesting. Seedlings grown in the light, seedlings grown in the dark. So that is what we have manipulated. We are seeing what happens when we change this. So here we have our independent variable. If we summarize it as a variable rather than the two options, it is light conditions. Okay, so before we're even getting there, we're keeping track of what's going on. Okay, so here's our beautiful seedlings. And we are told, you are going to measure the length of the coleoptiles and the total length of the seedlings visible above the soil. You will measure all the seedlings grown in the light and all the seedlings grown in the dark. Now don't freak out. The previous page in this question paper actually had a beautiful little diagram which showed you where a coleoptile was. Okay, and it is this piece here. Okay, so it's shorter on these ones in the light and longer on these ones in the dark. Okay, so this one is one where we are actually going to use our ruler and measure. So this is another type of question. Okay, in this one, you're going to measure something yourself. Okay, so whenever you're measuring, remember that they're going to give you some flexibility in terms of the answer, because they understand that your ruler and my ruler and their ruler are not necessarily the same. But there's a boundary of acceptable answers. So I was a very good student. I printed off this page and measured it with a ruler on paper. And what I got was coleoptile readings of 22, 23, and 22. And total length readings of 58, 58, and 57. And then for those in the dark, I got coleoptiles of 66, 64, and 73, and total lengths of 86, 81, and 101. So now we have to make one table that is sensible and logical and has all 12 of these numbers in it. So we're going to think about it with our pencils in our hand again. Okay, so one table. We're going to have light and dark. Okay, because we've already established this is our independent variable. Now we're going to have two columns because we're going to have coleoptile and we're going to have total. Okay, but now we've got to think about it because we've got 3 of each. Well, we can just add in another label. So trial 1, trial 2, trial 3, trial 1, trial 2, trial 3. So we know that light, coleoptile, 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 total, light, light, light. Okay, so when we're looking at our dependent variable, we can add columns if we have multiple trials. So let's turn this into a beautiful table. Okay, take a note that you've got 6 marks now. More marks because you're doing more work. So, using our full space wisely, pencil and a ruler. These are beautifully straight lines, as I'm sure you can see in your vivid imagination. Okay, we're going to need a relatively skinny column for this bit, and then we're going to need wider columns because remember we're going to split them. Okay, so there's our heading for the whole column, and then we're going to indicate our trials. So here we're going to split into 3. Okay, then this one we're going to extend across because that's the end of the heading for this column. And then we just need light and dark. So table is set up. We change to our pen, black or dark blue, to fill in. What was our independent variable? It was the light conditions. Okay, we have to have a heading in the top of that column. Okay, and we have seedlings in the light and seedlings in the dark. Okay, they want the measurement of the coleoptiles and the total length. So this one here will be coleoptile length. Our units, when we measure in bio, we measure in millimeters. And here we have seedling total length. Again, measure in bio, measure in millimeters. And then we have trial 1, trial 2, trial 3. And again, trial 1, trial 2, trial 3. And then we can go and fill in our data. So coleoptiles for the light, 22, 23, 22. Seedling totals for the light, 58, 58, 57. In the dark, I do have this on a piece of paper beside me. I am not remembering all these numbers. Coleoptiles in the dark, 66, 64, and 73, 86, 81, and 101. So you can go here and you can say, look, there's my 3 trials for the light, there's my 3 trials for the dark, and you can start to see patterns within the data already because your table is neat and tidy and easy to read. Okay, so we have 5 minutes left, so we are going to keep moving relatively swiftly so that we can get through this last example, because he is giving us an example of another different style. New color. Right, so going all the way back to summer 2014, paper 62. A student investigated the effect of surface area. There it is, ding, 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 ding. The effect of surface area on the rate of digestion of food, meaning that our independent, if you can spell it, independent variable equals surface area on the rate of digestion of food by observing color change in agar jelly pieces placed in dilute sulfuric acid. There is a lot more information in this question that I didn't copy paste. And given the time constraint, we are going to not even read all of this properly. Okay, so we end up with 4 large test tubes and 4 agar blocks, which we cut into different surface areas. Okay, we have surface area A, B, C, and D. Then the student timed all these things and they wrote down their results. Okay, and here we have them. Block A, 12 minutes, block B, 6 minutes, 25 seconds, block C, 2 minutes, 40 seconds, and block D, 4 minutes, 10 seconds. There's nothing we can do with that. There is not 1 unit here, there is 2 units as minutes and seconds. Bear that in mind. Use the space below to draw a suitable results table for this investigation. The thing is, if we have minutes like 5, 10, 15, 20, we can call it minutes. Time taken of the measurement, minutes. Happy. As soon as we get minutes and seconds, we're not happy. Okay, we can't put 6, 4. I mean, what's our header going to be? How are we going to say that's the minutes, that's the seconds? So we must convert everything to seconds. So block A, 12 times 60 equals 720. Block B, 6 minutes times 60 seconds plus 25 seconds equals 385. Block C, 2 minutes times 60 seconds plus 40 seconds gives us 160 seconds. And block D, 4 times 60 seconds plus 10 seconds equals 250 seconds. So here is your third type of question, working with time results. So you need to be comfortable with the fact that if it's mixed, we must take it down to seconds. So we are now going to high speed through our table. Luckily, this preparation that we have done here is setting us up, okay, because we said we have blocks with different surface areas, and we have time taken in seconds, and A, B, C, D. Okay, so your scrappy little rough table doesn't have to be beautiful, it just has to be informative to yourself. Ruler and a pencil. I talk too much in these lessons. I know my heading here is going to be shorter, so I make my column narrower. Give myself space, and then give myself 4 rows for data. Okay, in pencil, with a ruler, now we switch to our pen. This here is going to be our block. So A, B, C, D, and this is time taken to change color in seconds. Not time, because time could be time taken to eat an apple. Okay, time taken to change color, be specific. And then we put in our second values. So 720, 385, 160, and 250. And hey presto, we have another neat, tidy, beautifully informative results table. So please bear all these things in mind as you are going through and you are doing alternative practice, or you're reading about practicals, or you are doing your practical practices, or you are reading practice in your book. Always think in terms of how would I do my results table from this. Okay, if you want the notes, then please send me a message on chat and I will send them through to you. Otherwise, have a wonderful rest of your Monday, a wonderful rest of your week, and I shall be seeing you for next week's live lesson. Have a good one, guys.